1.1.4. Identify and combine like terms. Algebraic expressions are made up of terms. A term is a constant, or the product of a constant and one or more variables. A term. A term is a constant or the product of a constant and one or more variables. Examples of terms are 7y, 5x squared, 9a, and b to the fifth power. The constant that multiplies the variable is called the coefficient. B. Coefficient. The coefficient of a term is the constant that multiplies the variable in a term. Think of the coefficient as the number in front of the variable. The coefficient of the term 3x is 3. When we write x, the coefficient is 1, since x equals 1 dot x. Some terms share common traits. When two terms are constants or have the same variable and exponent, we say they are like terms. Look at the following 6 terms. Which ones seem to have traits in common? 5x, 7, n squared, 4, 3x, 9n squared. We say 7 and 4 are like terms. 5x and 3x are like terms. N squared and 9n squared are like terms. C. Like terms. Terms that are either constants or have the same variables raised to the same powers are called like terms. If there are like terms in an expression, you can simplify the expression by combining the like terms. We add the coefficients and keep the same variable. Simplify. 4x plus 7x plus x. Add the coefficients. 12x. Example 1.7. How to combine like terms. Simplify. 2x squared plus 3x plus 7 plus x squared plus 4x plus 5. Solution. Step 1. Identify the like terms. 2x squared, x squared. 3x, 4x. 7, 5. Step 2. Rearrange the expression so the like terms are together. 2x squared plus x squared plus 3x plus 4x plus 7 plus 5. Step 3. Combine like terms. 3x squared plus 7x plus 12. Try at 1.13. Simplify. 3x squared plus 7x plus 9 plus 7x squared plus 9x plus 8. Try at 1.14. Simplify. 4y squared plus 5y plus 2 plus 8y squared plus 4y plus 5. How to combine like terms. Step 1. Identify like terms. Step 2. Rearrange the expression so like terms are together. Step 3. Add or subtract the coefficients and keep the same variable for each group of like terms. 1.1.5. Translate an English phrase to an algebraic expression. We listed many operation symbols that are used in algebra. Now, we will use them to translate English phrases into algebraic expressions. The symbols and variables we've talked about will help us do that. Table 1.2 summarizes them. Operation. Phrase. Expression. 1. Addition. A plus B. A plus B. The sum of A and B. A increased by B. B more than A. The total of A and B. B added to A. 2. Subtraction. A minus B. A minus B. The difference of A and B. A decreased by B. B less than A. B subtracted from A. 3. Multiplication. A times B. A dot B. A times B. A times, open parenthesis, B, closed parenthesis. Open parenthesis, A, closed parenthesis, times, open parenthesis, B, closed parenthesis. The product of A and B. Twice A. 2A. 4. Division. A divided by B. A divided by B. A over B. A divided by B. The quotient of A and B. The ratio of A and B. B divided into A. Table 1.2. Look closely at these phrases using the four operations. The sum of A and B. The difference of A and B. The product of A and B. The quotient of A and B. Each phrase tells us to operate on two numbers. Look for the words of and to find the numbers. Example 1.8. Translate each English phrase into an algebraic expression. A. The difference of 14x and 9. B. The quotient of 8y squared and 3. C. 12 more than y. D. 7 less than 49x squared. Solution. A. The keyword is difference, which tells us the operation is subtraction. Look for the words of and to find the numbers to subtract. The difference of 14x and 9. 14x minus 9. B. The key word is quotient, which tells us the operation is division. The quotient of 8y squared and 3. Divide 8y squared by 3. This can also be written 8y squared, fraction slash 3, or 8y squared, over 3. C. The key words are more than. They tell us the operation is addition. More than means added to. 12 more than y. 12 added to y. Y plus 12. D. The key words are less than. They tell us to subtract. Less than means subtracted from. 7 less than 49x squared. 7 subtracted from 49x squared. 49x squared minus 7. Try it 1.15. Translate the English phrase into an algebraic expression. A. The difference of 14x squared and 13. B. The quotient of 12x and 2. C. 13 more than z. D. 18 less than 8x. Try it 1.16. Translate the English phrase into an algebraic expression. A. The sum of 17y squared and 19. B. The product of 7 and y. C. 11 more than x. D. 14 less than 11a. We look carefully at the words to help us distinguish between multiplying a sum and adding a product. Example 1.9. Translate the English phrase into an algebraic expression. A. 8 times the sum of x and y. B. The sum of 8 times x and y. Solution. There are two operation words. Times tells us to multiply, and sum tells us to add. A. Because we are multiplying 8 times the sum, we need parentheses around the sum of x and y. Open parenthesis, x, plus, y, closed parenthesis. This forces us to determine the sum first. Remember the order of operations. 8 times the sum of x and y. 8, open parenthesis, x, plus, y, closed parenthesis. B. To take a sum, we look for the words of and to see what is being added. Here we are taking the sum of 8 times x and y. The sum of 8 times x and y. 8x plus y. Try it 1.17. Translate the English phrase into an algebraic expression. A. 4 times the sum of p and q. B. The sum of 4 times p and q. Try it 1.18. Translate the English phrase into an algebraic expression. A. The difference of 2 times x and 8. B. 2 times the difference of x and 8. Later in this course, we'll apply our skills in algebra to solving applications. The first step will be to translate an English phrase to an algebraic expression. We'll see how to do this in the next two examples. Example 1.10. The length of a rectangle is 14 less than the width. Let W represent the width of the rectangle. Write an expression for the length of the rectangle. Solution. Write a phrase about the length of the rectangle. 14 less than the width. Substitute W for the width. W. Rewrite less than is subtracted from. 14 subtracted from W. Translate the phrase into algebra. W minus 14. Try it 1.19. The length of a rectangle is 7 less than the width. Let W represent the width of the rectangle. Write an expression for the length of the rectangle. Try it 1.20. The width of a rectangle is 6 less than the length. Let L represent the length of the rectangle. Write an expression for the width of the rectangle. The expressions in the next example will be used in the typical coin mixture problems we will see soon. Example 1.11. June has dimes and quarters in her purse. The number of dimes is 7 less than 4 times the number of quarters. Let Q represent the number of quarters. Write an expression for the number of dimes. Solution. Write a phrase about the number of dimes. 7 less than 4 times the number of quarters. Substitute Q for the number of quarters. 7 less than 4 times Q. Translate 4 times Q. 7 less than 4Q. Translate the phrase into algebra. 4Q minus 7. Try it 1.21. Jeffrey has dimes and quarters in his pocket. The number of dimes is 8 less than 4 times the number of quarters. Let Q represent the number of quarters. Write an expression for the number of dimes. Try it 1.22. Lauren has dimes and nickels in her purse. The number of dimes is 3 more than 7 times the number of nickels. Let N represent the number of nickels. Write an expression for the number of dimes.